Hi everybody, thanks for tuning in. I hope you guys are doing well. It's been kind of a strange ending to our semester, but anyway, we're getting ready for this last test in our class, and what I'm going to do here is make 3 videos. The first one will be on inverses, like it says. The one after that will be on logarithms, and then the third one will be on polynomial functions. All right, so just a couple of things to keep in mind here about inverses. The first thing I wanted to mention was if your job is to sketch an inverse, okay, I thought I'd just draw kind of a strange looking function for you right here. Here's a function that has a couple of endpoints here that it goes through, and then another point here, and then it just kind of goes up in this curve here. When you sketch an inverse, remember, you are reflecting it across the line y equals x. So that's probably one of the first things that you want to do on your sketch, is to try and sketch that line in y equals x. It just goes through a 45-degree angle right through the origin. And then the other thing to take note of when you're sketching an inverse is that the x and y coordinates of every point are interchanged between the function and its inverse. So there's a point -4 and -6 on this function. Well, that means that there's a point -6, -4 on the inverse. So you can kind of start off by going sort of point by point, and those points should reflect directly, in a perpendicular way right across that line of reflection, the line y equals x. So I would get that point figured out, and then the next point I'd do would be over here. 1, -1. 1, -1 would be another point on the inverse. So got that, and then I'm just going to connect those with a straight line, and it should be something kind of like that. All right, didn't do such a straight line there, but that's what it should look like. If your function crosses the line y equals x, then your inverse will also cross the line y equals x at exactly the same place, right there. So then, to continue then, here's another point, 5, 2. So my inverse point would be 2, 5. So 2, 5, let's just kind of, this isn't exactly to scale, it's not graph paper as you can see, but it's going to be up there someplace. And so I'll connect those two with a straight line, and notice once again, it goes right through that same intersection point of the curve and the line y equals x. And then the last point would be this curving part, and so you just do your best to try and sketch in that inverse for that curve. So that's one thing you'll be able to do, and they should be symmetrical around this line of y equals x when you're all done. Okay? Another thing you're going to do with inverses is find the equation. So here's a couple of equations to just do here, and we've done this many times. It's a pretty simple process. First, you just interchange the x and y variables. So instead of y equals 1/2 x minus 3, just go ahead and write x equals 1/2 y minus 3. And then you solve it for y. This one's going to be pretty easy. X plus 3 over here on the left side equals 1/2 y. And then just multiply by 2. And so you can write it as 2 times x plus 3 equals your inverse equals y. If you want to distribute, that's fine. 2x plus 6, they're both good. Doesn't really matter. Both of those are the inverse functions, okay? If you have an exponential function, remember that the inverse of an exponential function is a logarithmic function, okay? So we'll do the same thing here. We'll interchange the x and y, so we'll have x equals 3 times 2 to the y. And now we're going to solve for y. Well, before you take the log of anything, you want to isolate that exponential part. So we're going to divide by 3 first. So you'd have x over 3 equals 2 to the y. Now, there is kind of an easy approach to this. If I write, so this is kind of my inverse equation right here. I don't have it solved for y yet, but I did interchange the x and the y variables. So all you need to do really is put it into y form. The easy way is to do this, if you think about, a log function, all right, and the base of my exponential function is 2, so I should have log base 2, and it's going to be 2 to the y equals this x over 3 thing. So if you just kind of play with that little snail pattern, as we call it, all right, there's your inverse function right there. Log base 2 of x over 3 is the inverse function to this exponential function here. If you wanted to kind of take a more systematic approach and write it in a different way by taking the log of both sides of our equation to solve for y, that's a good, that's a very dependable process. It's a few more steps, but log of 2 to the y, all right, taking the log of both sides. And then if I move this exponent y down in front, so y times log of 2, all right, and I've got log of x over 3 over here still. And now I'm just going to divide. Now remember, these are log base 10, okay, and you'll get an equivalent inverse expression just by dividing by the log. And this is a process we use for solving exponential equations, so it's good to revisit this. So you'll just have this expression right here, log of x over 3 divided by log of 2 equals y. And that's your inverse function. It's clearly a lot more complicated looking than log base 2 of x over 3, but this equation here, it's nice and tidy and simple looking, is the same thing as this, okay? So they are equivalent equations, and so there's a couple of examples of finding the inverse equation from a function once you're given the equation. Okay, I think that'll do it for this little video here, and thanks for watching. Bye.